to say thank you very much for joining us for Coreum's first workshop of the year, and this is going to be for Intro to Smart Tokens. My name is Lamont. I'm the Dev Relations Manager for Coreum. And Keen, would you mind introducing yourself?
Yeah, sure. So hello everybody, my name is Keen. I'm the Rust Smart Contract Developer for Coreum. And today we're going to have a short workshop introducing our smart tokens for our chain. So I think we can get started, right? Because we have a lot to cover. So Coreum is a layer 1 blockchain. It's mainly focused on smart contracts. And also our main feature is called smart tokens. So I'm going to introduce very quickly what smart tokens are. So we have two kinds of smart tokens in our blockchain. One is called asset FT, and the other one is called asset NFT. Like you can see by name, FT is for fungible tokens, and NFT is for non-fungible tokens. So why do we call them smart tokens? Well, they are on top of being native blockchain tokens. So they are not CW20 tokens. They are native tokens that are going to be stored in our bank module. We can additionally give them specific features. So we can actually issue tokens, smart tokens, giving them a specific set of features, so that in the end, we can create native blockchain tokens that do what we want them to do. Let me give you a quick example. For example, we can create a native token and we can say, okay, I'm going to allow my token to be minted. I am going to allow my token to be burnt. But for example, I'm not going to allow my token to be IBC transferred. So in the end, what we have is a sort of token, like a way to create tokens, but with powerful features to adapt to our use case. Okay? So let me also quickly show our CoreumWASM SDK. So we have to do this, we have a Rust crate that we call CoreumWASM SDK that I'm going to go over now. You can you can search it here in Coreum Foundation, CoreumWASM SDK GitHub repo, or you can actually go to the Rust crates and find it there. The code is also there, okay? So for example, here, I have a smart contract. And in this smart contract, we are going to work with our asset FT smart token module, okay? So the most important thing is, in our dependencies of our smart contract, we are going to have this CoreumWASM SDK dependency. So this CoreumWASM SDK dependency, it contains all the tools that we need to interact with our native Cosmos SDK modules so that we can use them in our smart contract. Okay, so every time we implement a new feature to our smart tokens, we will also update our repository, and it will automatically upload the new version to crates.io, so you can have the latest dependency in your project. Okay, so we have the CoreumWASM SDK here. Let's cover it quickly. So our WASM SDK has several modules. One is the asset FT module, like obviously this has the tools to access our FT module. Then this one is the asset NFT module to access the NFT module. Then we have core functionality that I will show a bit later. And then we have this NFT. This is the standard, this is the NFT module that exists already in Cosmos. But actually, we're not going to really use it because we have this one that is more powerful. And at the same time, this one is built on top of the NFT one. So we added this here because we still want to allow people to interact with the NFT module. But this one is more powerful, and it's built on top of the NFT. So everything you can do here, you can also do here. Okay? Let's go a bit quickly into the asset FT. So here we have let's scroll down. Here we have all the messages that our asset FT module has, like that can process, right? We have issue, we have mint, we have burn, freeze, unfreeze, globally freeze, set whitelist limit, and upgrade token V1. We are going to cover all of them. And here we have the queries. The queries are well, they are self-explanatory. You can query the parameters of the module, query the tokens of the module by issuer. So they don't really need to be explained. So this is a smart contract that we made. Okay, we call it FD. And what this smart contract does is when we instantiate the smart contract, we are going to issue a smart token. So the issuer of the smart token is going to be the contract itself. Let's look at the instantiate message very quickly. So let's say I want to create a token and the symbol, I want it to be, my symbol is going to be, for example, my token. And the subunit of the token is going to be my token. For example, for the Coreum token, as you know, the symbol is core and the subunit is ucore, right? So for this one, we're going to do the same. We're going to create my token and I'm going to create my token as subunit. We can also say what precision we want on our token. So let's say, for example, we want to create a token with 6 precision. This means my token would be equal to 2, 3, 4, 5, 6 my tokens, right? This is the same as Cosmos chains, other Cosmos native tokens. But if we want it to be, for example, 10, then we can make it 10, and then instead of 6, we will have 1, 2, 3, 4, 10. Okay? We can also choose the initial amount that will be minted when we issue it. So for example, if we put 0 here, the initial tokens will be 0. There will be no supply. Okay, but if we say, okay, we want to issue 1,000 tokens at the very start, so it will issue these tokens. Okay. We can add a description, whatever we want. And the most important thing that we have is the features. What are the features? Let me quickly go to the documentation and show you. So we have a set of features on our tokens. Right now, our blockchain is still in version 1, but the proposal for version 2 is already up for voting. So right now we have 4 features, but starting next week, we will have 5 features, which includes IBC. So for now, we have minting, burning, freezing, whitelisting, and next week we will also have IBC. So let's say I want to create a token, and I only want to allow the issuer to mint and to burn. I don't want to allow him to freeze, and I don't want him to allow to whitelist or to IBC. So we will have an array. This one is 0, this one is 1. So we are going to do, for example, we are going to pass an array of values, 0 for minting and 1 for burning. Imagine I want to also enable IBC. So I will be 0, 1, 2, 3, 4. I will pass an array, 1, 4. So in this array, I am saying what features my token is going to have. And these features cannot be modified. So once we create a token with these features will be not modifiable, at least with the current version of smart tokens. Maybe in the future, we will decide to allow people to modify. But at the moment, we don't allow these features to be modified. And finally, we have a burn rate, which basically the burn rate is, it's also explained in the documentation. The burn rate, to explain it very quickly, is if you say, for example, 10% burn rate, it means that every time someone sends a token, an additional 10% of that token will be burned from the sender's address. And the send commission rate means every time you send a token, for example, if it's 0.2, an additional 20% of that amount will be sent to the issuer of the token. So basically, what does our contract do? It issues a token with all these fields that I mentioned to you, and for convenience, it will save the denom of the token. So you will ask, how are these tokens stored into the bank module? Because they need to be unique, right? So the denom of the token, for example, for core, we know that the denom is ucore. Okay. For our token, it will be the subunit and the issuer's address, which in this case is the contract's address, because the contract is the one issuing the token. I'm gonna show you quickly how it would look if I query for example, this wallet here. Let me make it a bit bigger. Maybe you can't see. Okay. So you can see here, I queried my wallet, and you can see this long denom here. So this will be the denom of our smart token. It is basically the subunit, which in this case I called UTT2. And this is the address of the issuer, which in this case is the address of the smart contract I used to issue the token. Okay? So now that we have the smart token in our contract address, let's start doing things with it, right? For example, let's imagine we want to mint some tokens. So we are going to come here. We create a mint execute message. We have it here, mint with an amount. So let's go back. We have a mint function here. Okay. We check that the owner, that the one sending is the owner of the token. Okay, that we stored before. And we load the denom because this is the token that we are going to mint. It's the one we issued before. And we simply send an asset FT message mint with the amount and we mint it. That's it. So once we execute this message here, and we send it in the response, this will mint as many tokens as we indicated in the execute message that we sent. Okay? So for example, if initially I put initial amount, I have 0, and I decide to mint 150, then my contract will have a balance of 150. Okay? And it's pretty much the rest for like the same for all the other features. Let's imagine we want to burn tokens. We do the same as mint. We go here, we choose a burn message of the CoreumWASM SDK. We input the amount, and this will burn the amount of tokens that we want to burn. Okay? It obviously only burn tokens that are in the smart contract. You will not be able to burn tokens that are in someone else's wallet. Right? Then we have the same for freeze. So what does freeze mean? I didn't explain it before. So one of our features is called freeze. It's explained here. Okay. And when freezing is enabled on a token, we can decide to freeze the token. So the issuer of the token can decide to freeze tokens of someone else. What does it mean? Let's imagine that I sent you 150 tokens, and then I say, okay, I'm going to freeze those tokens. Once I freeze them, you cannot send them anywhere. They're basically stuck in your wallet, and you cannot move them from there. Okay? So let's imagine we have a bank. A bank issues their currency on our chain, okay? And this bank has a client which, I don't know, didn't pay the bills or whatever. They can say, okay, I'm going to freeze this person this amount because he did this thing, okay? And the same way we freeze, we can unfreeze tokens. So this is one additional feature of our smart token. We also have the globally freeze. That means you freeze all the tokens in circulation. It means nobody can send these tokens anymore. Only the issuer of the token can send the tokens. All this that I'm explaining is explained in the documentation. Okay, so if you can also ask me, but it's all very detailed here in the documentation. And the same way we have globally freeze, we have globally unfreeze. Okay. And last one, we have the whitelisting. What is the whitelisting? So if we have the whitelisting feature enabled for our token, before we are able to send tokens to someone, we first have to whitelist his address. And we whitelist it with a certain amount. So for example, if my token has the whitelisting feature and I want to send you tokens, first I have to whitelist you with the amount of tokens that I'm going to allow you to have, and then I will send the tokens to you. So this is the functionality of the whitelist. And the last one that we have is upgrade token. You say, why do we need to upgrade token? So, well, this has a specific use case. So our current blockchain is in version 1, and there is no IBC in our blockchain, right? So imagine you created a token in our blockchain before the IBC upgrades, but you still want to have the IBC feature, right? So we are going to give the option to all the issuers of tokens that are issued tokens before the upgrades to use this upgrade token V1 message to enable IBC for their tokens. But basically, it's very, like you can see query token, you query the token and it will tell you the token response. You can go into token response and you can see it will give you information of the token, all the token, like the version, all the features and everything. Okay, so the queries basically are to get information for the module. So let's say, for example, we want to make our contract to be able to mint tokens and send at the same time. So here, for example, we will have the message mint and the message send. So basically what we're saying is first mint the tokens and then send the tokens. Here we're using sub message, but we are not really using the reply on. So let me quickly make this a little bit better. Let me change this. So we are going, instead of using sub messages, let's change this for messages here, which will give an error. Let's do something here. Let's change this to Coreum message. Sorry, Cosmos message from. Okay, we will have a Cosmos message, and let's change this to, for example, let's send message equal Cosmos message bank. Yes. So instead of creating sub messages, because we're not really using the sub message features, we are going to basically copy this here. This is a bit of live coding. I hope this works, or I will embarrass myself. We do this, and this should work. Yes. So basically, since we were not using sub messages, I changed this for Cosmos messages instead. This is basically this message will fire and forget. Okay. And as you can see here, we can use we can do Cosmos message from. If we go into here, why can we do this? How do we allow to do this? So let me remove this that we're not using anymore. So if you go into the CoreumWASM SDK and you go into the core functionality, you can see that we have implemented the from for Cosmos message. So when we do from a Cosmos message, it will transform it into a custom message, because CoreumWASM only has an API for the standard messages, but since these messages are custom messages because our modules are specific to our blockchain, we have to actually use a wrapper for a custom message. Okay, and the same for queries. We have a custom query for Coreum queries. Okay, so that's why this works. If you are wondering why, how can he actually, where was I before? Here, how can he actually do this? Well, I can do it because our CoreumWASM SDK has this implemented. Okay. So that's it. That's it for asset FT. So before I go into asset NFTs, do you have any question?
It looks like we may have one question in the chat right here. And he's particularly asking us, how long is the team expecting for the mainnet to be down while IBC and these other upgrades are being implemented on Coreum's end?
I mean, the upgrade depends on the validators. It doesn't take much time. It can be like a couple hours or so. I'm not sure how long upgrades take. I don't think it will take long, not much. Like, it depends on the validators, how fast they upgrade. So basically how upgrades work is we put up a proposal. We say to the validators, here is the binary file. And at this block, all of you are going to upgrade. So basically, once we have 66%, so we have consensus, the chain will continue. So it basically depends on the validators how fast they upgrade. So let's go say let's forget about asset FT for a second, and now let's go to asset NFT. So asset NFT has a very similar functionality as asset FT, but obviously it's like for non-fungible tokens. So basically what we are doing here, we are going to issue classes. So the class will be the representation of the NFT, and then we will be able to mint NFTs from this class. Okay, so in this contract, for example, we send all the information. We send what be the name of the collection, so to say. So let's say, call it my NFTs. Sorry, let's call it, I'm making a mess here. Let's call it my NFTs. The symbol will be, I don't know, my NFTs symbol. Description optional. URI is the link. URI hash is also optional. I will keep everything optional. We allow our NFTs to have data. So basically in this data, you can put anything you want. I mean, imagine you want to send a PDF to someone in an NFT. You can basically encode that whole PDF here, and you're basically sending an NFT to someone that is a PDF. Okay. You want to make, I don't know, anything you want. This is binary. This is basically what binary is a base 64 encoded array of bytes. So you can send anything you want here. Okay. And this will be stored in on-chain. And then we have the features. So if we look at the features of the NFT, let's go here. We have this list of features. We have burning, we have freezing, we have whitelisting. So I think these three are self-explanatory, are the same as an NFT. We have disable sending, which is basically we don't allow the NFT to move anywhere. Like basically, only the issuer can have it. And then we have royalty rate. So royalty rate is a feature that will, once we have the DEX live, we will, every time an NFT is sold, it will send a percentage of that price to the issuer of the NFT. Okay. So here, for example, we have, why do we have this disable sending? How does it make any sense? Well, here it explains. So this feature opens the door for different use cases. Imagine you don't want to allow sending NFTs because you want to force people to go through the DEX to trade their NFTs, right? So imagine if you allow sending, then people could potentially skip the royalty rate if they trade peer-to-peer, right? But you say, okay, I don't want people to skip the royalty rate, so I'm going to disable sending so that they are forced to go through a DEX to trade this NFT. Okay, I hope that makes sense. The same as like FT, we have all the documentation here. So if you want to go more into detail, everything is very explained in detail here. So like we did before, we have here, we send all the information, and in the contract we issue the class with the name, the symbol, description. So basically we copy what we send to the contract. Okay. And how is the class ID saved on the blockchain? It is saved with symbol. So what we wrote in the second field, my NFTs, dash, and the issuer, in this case the contract. Okay. We are going to save this for convenience, the same as we did before, and then we basically, this contract is now the issuer of this NFT class. What can we do? We can mint NFTs. So for example, we can say we're going to load our class and we're going to mint an NFT with this URI, this hash, this data. So each NFT can also contain data. We also have a binary field for each NFT, so we can store any information we want there. And we will mint with a certain ID. For example, normally NFTs, the ID is a number that goes up, right? So you can say, okay, I'm going to mint 1, 2, 3, 4, 5, 6, 7 in ascendant order. And I can, for example, store here, I can make a, for example, if I don't want to pass this as a message, here in the message mint, if I don't want to pass this here, I can actually store in this contract a counter and I can use that counter. Okay, that's what normally minters do in other platforms. We have the burn. Burn is the same logic. You take a class, you burn from this class, you burn this ID. Okay, the same freeze. We freeze a certain ID. It means the owner of that NFT cannot send that NFT anymore. Unfreeze is the same as with asset FT. If it's frozen, we can unfreeze it so the owner of the NFT can send it again. And for whitelist is the same as before. We have to whitelist an account so this account can receive this particular NFT.
Keem, okay. We just had one quick question that came out here in the chat, which is just kind of asking overall the team, are you guys working on a DEX interface for people who have issued smart tokens?
Yeah, so actually we have Alberto. He actually has already a front end for this. I don't know if it's live yet. He showed me a demo last week. I think you were there too, Lamont, and it was actually quite advanced. It worked perfectly. So I think we already have something for this. I think he's polishing it a little, and he wants to have more features in it before he releases it.
Yeah, it has not been released soon, but when it is, we will definitely be making announcements and letting everybody know.
anybody can create their own front end and create their smart contract and everything, right? Like anybody, like this is permissionless. Anybody can do it. I know people who are already doing it and have already something. So it will be live soon for sure. So as I said before, we have the send NFT here. So basically, since we said the asset NFT module is built on top of NFT, for example, for send, we are using the message from the NFT module because it's already implemented there. So we didn't need to re-implement something in asset NFT module that is already implemented NFT module. So you will see here, for example, instead of using asset NFT, we're using NFT because they have the function send. But it's not really a big deal because you only need to change this thing here, okay? And if you can see, the messages are here. The only message it has, actually, it's send. So for sending, we are using this that is already implemented, okay? Okay, so we have here, okay, let me point out. So for example, these contracts here, they do very basic functionality. We have a tutorial here, and we have tutorials here. If you come here to our website, doc website, Coreum Docs, you can come here and you have like a lot of information for dealing with smart contracts. For example, we have a smart FT WASM, and where it gives you a link to the source code. And for example, we made a contract here. Let me show it to you. That does similar to what the one I showed you before does, but it actually implements an airdrop. So what this contract does is, it's all in the same contract. So let me find instances. So here, it issues an FT, it saves the denom, and it also stores some information so that we can use it to airdrop amounts later. Okay, so for example, we can mint for airdrop, and this will store the token in the states, and then people can claim these tokens from the airdrop. Okay, so for example, if you are curious about more functionality, you can come to the documentation and you can actually find more contracts that work with our custom modules. Okay. Anyways, like I told you as well, if you go to here to the CoreumWASM SDK repository, you have a link to smart contract examples, so you can come here, and you have a link to IBC examples, transfer and call. And you have also a link to go, for example, to modules. And in this, you even have an example how to use OddZ with contracts, which is quite cool. And here the FT and the NFT is the one that I showed you today. So if you want to get the source code, you can come here and use basically, yeah, you can get it from here. Okay, this is basically what I showed you today. Okay, so let's do something fun. Let's do some live coding. For example, I'm going to take my asset FT contract that I showed you before, and let's create a new message here. Let's go to message here, and we are going to create a message. For example, we're gonna say mint and IBC. Okay, we're gonna say mint and IBC. And we're gonna say the amount, how much we are going to send. And I think I have a token here, IBC transfer. Yes, so let me see here. So I need probably this information too. The point, I have it already. So I'm gonna copy this here and then I remove the amount. Let me go back to the first one. Let me copy here and I will remove the coin because I already have the amount. Okay, all right, let me in. I need the IBC, let me see 1 second. So for example here, I think the IBC transfer, we need to have a feature in the dependency. Yeah, so like you see here, the CoreumWASM STD, to find the IBC messages and structures, we have to add this feature here. So we're gonna actually copy this dependency and change it faster than just adding it again. So we're gonna add this here, IBC. And now we should be able, yeah, we already have the IBC timeout. You see that the error is gone here. Okay, so this IBC timeout is here. We have to import it, and it's gone. Okay. So what we're gonna do now in this session, we are gonna mint a token, and we are going to IBC it to the address of the chain that we want. Okay. For example, imagine that we want to mint a native token and we want to immediately send it to another chain. Let's imagine like the Cosmos hub or to Osmosis or something like that. So we can basically, here we're going to put the address of the wallet that we are going to send it to in the other chain. Okay. Like we can see here, now we have an error here because we don't have this message implemented. Let's add it here. We quick fix, fill the match arms, parse this. Okay. And we are going to add, we're going to call it mint IBC. Mint IBC. Let's call it mint IBC. We're going to pass depths. We're going to pass info. No, we don't need to pass info. And we're going to pass the amount, the channel ID, the to address, and the timeout. Okay? We're going to do something like this. We don't have this function, so let's add it here. I'm going to copy something. Let's copy it. Let's make it here. So we're going to mint and IBC. Sorry, mint IBC. We're going to add the depths not. We're going to add info, amount, which is amount, channel ID, which is a string, I think. It's a string. Yeah. To address, which is also a string. And we have a timeout, which is going to be an IBC timeout. Good, right? And this will send Coreum result contract. Okay. So we're going to create a function that mints an IBC. Let's do it. Let's copy the mint part that we already have. So we are going to, this thing is going to be the same. We're going to assert owner. Okay. Oh, we also need the info because we're going to need the owner. Okay. We're going to add this here. We're going to copy this. This is going to be the same, right? And now we're going to create an IBC transfer. Let's actually, I think we already have it in the example, so we can copy from there. We have an IBC transfer here. Okay, we have an IBC transfer message. Let's copy it. And then we have it here, IBC transfer message. We need to import this, okay? And the amount, why not amount? Because it is, we expect a coin, right? We need a coin, so we need to make amount needs to be a coin that is going to be the amount and the denom clone. This should work, yes. Okay, so now we have the mint message and we have an IBC transfer message. Now the only thing we need to do is we actually need to okay, we now write a response. Okay, response new. Add attribute. We're gonna call it mint and method. We're gonna call it mint and IBC. We're gonna say what denom it is. The denom is, for example, denom is denom. Of course, we have it here. And then what we're going to do is we're going to, let me parse this a little bit so it looks better. Sorry, we are gonna add the messages. First message is an array, so it should be message is the first one, and the other one is IBC transfer message. Let's change this to mint message so it makes more sense. Mint message. This gives an error because we have, we have two different kinds of messages, so we need to do what we did before. We're gonna do a Cosmos message dot from this, and now this should work. Coreum message, Cosmos message, IBC message, this is Coreum message. You know what? To solve this, we're gonna do something different. We're gonna add them one by one. Mint message, add message, IBC transfer message, and this should be fine. IBC transfer message from Coreum message. We need to do, let me see 1 second, Cosmos message. I know what happens. I think we need to do Cosmos message, IBC message, IBC. Wait, why is not finding here? Let me see 1 second. Like I said, this should be IBC. It should actually work. Let me see. This is what happens when you live code. So we have here IBC message is not satisfied. We need to do from, and I think this should work as well. Oh, we don't need this into, I think. Cosmos message, found Cosmos message. From transfer IBC. We can send it to sub message. We have the Cosmos message here, message, response. Okay, let me fix this 1 second. Because if we remove this, actually into IBC message. So we have here results. Actually, we can actually mint and send later. So we can do an IBC message. Okay, I'm going to figure out why this one doesn't work, and then I will upload it to the repository because it says it's complaining here about current results. It should have message. Cosmos message. Oh, here it is. Okay. Now we have it. There we go. And just we have this one here. Okay, that's it. That's what happens when you do live coding. So basically what we did is like we created a Cosmos message with IBC and we wrapped the transfer into the Cosmos message. So if we wanted to change it like we had it before with an array, we can go here, assets mint, messages, we can do an array, mint message and IBC transfer message. This should also work, okay? There we go. So this one here, what this does is basically we mint a token in the smart contract and we immediately transfer it to the channel ID. So if our chain is connected with another chain via IBC, it will have a channel. So we say, okay, send it to that channel. This is the address that is going to receive the token. This is how many tokens you are going to send through IBC. In this case, it's the same amount as what we minted. And here we send the timeout. In this case, we send the timeout in the message that we execute. But we could, for example, put here a date. It will also work. Okay, we could do something like IBC timeout. If we have it here, IBC timeout. Timeout to IBC timeout with timestamp, and we can have a timestamp here. Timestamp from seconds, and here we would put the seconds. We would add the seconds of the block. For example, let's put it. We need to pass the M here. For example, let's pass the M here. Okay, and we pass the M here. Okay. Sorry, we're not using it, so I'm going to add it. There we go. So what we can do is M block time seconds, and we can, for example, add to this 120 seconds. What this is like what we're saying is our IBC transfer will time out in 2 minutes. Okay. In this case, I sent it in the message, but for example, what I did here, instead of using the one I sent in the message, I made it 2 minutes. Okay. And that's pretty much it. And I think in 10 minutes, we implemented the function that mints tokens sends IBC, and done on the spot. So, which is pretty cool.
Keen, I want to say thank you so much for doing this. It's very much appreciated.
Yeah, no problem. That's what we're here for. So if nobody has questions or they don't have any questions now, and maybe later they check the documents and they don't know how to do something or they really don't understand something, I think they can ask either Lamont and Giovanni, and if you don't know the answer, you can redirect it to me and I can answer, no problem. So basically that's it. That's it, guys. So we have 2 modules, the FT module, NFT module. And with smart contracts, you can do everything. You have access to all the tools to use the full power of the modules. And actually, the modules, like the smart tokens, are very powerful because we can choose what we want them to do. Like we can even, like we have full control over our native tokens.
In 2 weeks, we will be having another workshop. And once again, folks, just stay on the lookout in our announcements. My name's Lamont. This was Keen once again doing this. And we say, everyone, have a great rest of your day. Thank you for joining us.